beverage with them? That I see a bunch of this size. What is this?
I think it's a 16.
Is that a 16?
Yeah.
How many 16-ounce beverages do we have with us today? Let's see hands on 16 ounces. We got 1, 2, 3, 4, 5, 6 16-ounce beverages. Okay. I've got, this is a 21.
Yeah.
This is a 21. I got a 21 as well. We got 21, 21, 21. I think it was 21 ounces. What a weird number.
Yeah, I got 20.
20? So we've got 20. We've got 21.
I have 14.
We've got 14.
15.2. 12.
I started this, didn't I? 12. What other size? Let's just do it this way. What other sizes do we have?
Oh wait, mine's
32.
15.2.
15.2?
33.
32, that's a quart. Next one.
Liter.
What happened to just quart bottles, right?
33.
33, of course, Coke had to put an extra ounce in. Is it? Oh, it's a liter, isn't it? The 33 point whatever. Yeah, it's a liter. It's a liter. Yes, we'll call it 33. That's good. We got
40.
40. Mimi's got the big hydro flask. Okay, I love it. So let's take a number now of how many of each of these we have. How many 14 ounces were there?
1.
There's just one of those? Okay. How many 16 ounces? 1, 2, 3, 4, 5. I got 5. Okay. 20 ounces. 2 of us. Yeah, 2 of 21. I'm in that group. 1, 2, 3, 4. 15.2 ounces. I know there's one of you.
2.
There's 2 of you.
Sorry.
No, don't be sorry. Just be scientific. We're doing this together. This is great. 12 ounces. 1, 2. 32. You got the 1 quart. No, we got 3 quart bottles. Very nice. 33 ounces. Now, somebody had it. Oh, it was the 1. That's right. You got the raw. It's nice. 40. Maybe got the 40. Do I have everybody accounted for?
No, because you have 0.
0.
I mean, I don't have any.
Oh, good. No. That's the point.
Yeah.
That's the point. I wanted something that some of us had, but all of us didn't. Because even though you guys are at zeros, well, you know, mathematically, let's come back to that, Christina, because what you guys are on the cusp now of getting to what this idea of an average is. You guys are all saying the right things, but the problem is you're using terms like accuracy and margin. I'm not interested in the accuracy of the margin, but what the number actually means. Brittany, go ahead.
At least 2 of us have 2 beverages, so do you want us to...
Let's let it go for now if it's okay. Because, I mean, technically speaking, we could just loop your 2 together into 1. Is glass that bad? You have to drink that much? I'm sorry. Kidding.
It's for the
Terrible jokes. It's early in the morning. I know. I'm not quite tracking with you, Rule. You'll have to deal with it at 8:15. So, what you guys are about to do is called a weighted average. You're about to do what's called a weighted average. Now, you guys have done this before if you've ever calculated your GPA before. Anybody ever calculated their GPA? You guys have actually sat down and calculated it like out by hand?
Yeah.
Excellent. That is the most students I've ever had in a room that have actually done that. Most people just go to their transcript. And it tells you what it is, yeah? Not to mention, GradTrax tells you what it is and what you have to get in successive terms to get a desired GPA. That's pretty rad, too.
Yeah.
Jury, go ahead.
That's what I was going to tell you.
Oh, it's pretty cool, isn't it?
Yeah.
But, oh, it can totally do that. It's a planner. It's a planner feature. It's one of the few things. It's totally rad. GradTrax is bitchin'. I should tell Blackboard to email GradTrax. So, a GPA is what's called a weighted average. Do you know why a GPA is called a weighted average? I think we talked about this maybe briefly in here before. We did?
Yeah.
Do you remember why it's called a weighted average?
Because all the courses are weighted differently.
Right. So there's different weights of the courses. For example, if I wanted to know on average how much somebody in this room had with them as a beverage, you could just go this plus 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 this divided by 9. You could do that, but you'd be wrong, because that would assume that there are only 9 people in here holding a beverage. How many people are in here holding a beverage? What part of this data chart tells you how many people are in here holding a beverage?
Right.
Right-hand side.
Yes. So how many beverages do we have? Well, let's count them up. We've got 6, 8, check me on this, 12, 14, 16, 21. I get 21 beverages. We'll let the other 2 go. Brittany, she's left anyway. She's had enough. So I'm going to go ahead and call that n equals 21. I'm going to start using the letter n around you guys because I want to get you comfortable with that as we go through the course. N would be a sample size. So what a sample size would be. And you're going to get used to this, especially if you're taking 243 later on. So I'll start using that now. Not 9. There are 9 categories of discrete drink sizes, some of which are very, very close. We're also going to make the assumption they were all 100% full. That's not necessarily true, correct? Yeah, exactly. He's like, nope, not full. Exactly, almost empty. Need a refill. But we're going to make, for the sake of argument, we're going to assume they're all 100% full. So, suppose I wanted to know what the average volume of beverage that somebody in this room has. Suppose I wanted to know what the average beverage someone in this room has. Of the 21 that are having it. Christine, I'm going to come back to your point, all the zeros. We'll put those in as well, but not right now. Right now, I'm just going to deal with the 21 people that I asked about. How could I get that number? Now, Marichelle, you gave us a beautiful formula earlier. You told me to add things up and divide by how many there were, correct?
Yeah.
We know how many there are now. There are 21, correct? But what do I add up? Do I go 14 plus 16 is 30, plus 20 is 50, 71, 86.2. Put me out of my misery. Put me out of my misery. Negatory. No, stop, Sean. Stop right there. Why? Stop, Sean. Why?
Because you're wrong.
Well, why am I wrong?
Oh, because you're doing it wrong.
Okay, give me. Thank you, Josh, for correcting me twice without giving me any constructive criticism. Sumi, go ahead.
It's because there are 5 16 ounces.
Yes.
So that means there needs to be 16 times 5 plus 14 times 1, and you have to add all of those up.
Yes. Thank you, sister. These 5 16-ounce beverages represent, that's 80, not 90, isn't it? There's 80 total ounces of liquid from those 5 people. Yes? 80 total ounces of liquid. You can't just add 16 to 14 because that ignores that there are 4 other people that also have 16. This was done as a shortcut to save me from having to write 16, 16, 16, 16. We have to undo that by making sure we multiply it out. This is still 14, yes? This is still just 14 ounces. So if you want to think of it from a GPA perspective, this is total fit, this is Bio 211. 5 credits versus a 1-credit HHP class, yeah? This is why if you get, I don't know, a C in your bio class and an A in total fit, you don't have a B for a GPA. You've got pretty close to a C because the HHP 1-credit class only counts 1/5 as much as the C in the bio class counts. See what I'm getting at here? Mm-hmm. Cool. Okay, let's keep it going. There's 40 ounces here. You guys, your guys' job is to check my math, make sure I don't screw something up at this point. Okay? 421 ounces is 84 ounces. Okay? 2 15.2s is 30.4 ounces. Yes. 24 ounces. 96 ounces. 33 ounces. That's a Z. And 40 ounces. Why do we use OZ for ounces? Because we're Americans.
Right?
Because we spell everything wrong anyway. All right. So how many total ounces do you guys have? We're assuming, of course, these were all full bottles.
441.4.
Good job.
Thank you, Brittany. 441.4. 441.4 ounces. That's how many ounces we all had. 441.4, which would be a lot more than just adding this column up. Hopefully you realize that. Hopefully you get at that point. Good. So, to calculate the average volume of a beverage somebody who actually has one has, that's what we have to divide by 21, yes? 441.4 ounces divided by 21. Brittany, go for it, my friend.
21.01.
21.01. We can just call it 21 ounces if you want. So, those of us with hydro flasks are holding the average sized container, aren't we? In this room. We are holding the average sized container. We are average. Yay! We're average. So, what happened when we added all this up and divided by 21 and got 21 out. How does Mimi feel about this? She has a 40-ounce hydro flask back there, yes? So how does the 21 apply to her?
It don't.
But it does. It doesn't because she's above average. But it does because where's one of my 12-ounce cup people? So Chrissy, Mimi, you can walk over to Chrissy and give her some more ounces to bring her 12 up and bring your 40 down. Yes? Okay, and she's gonna have a little left over after that, I think, because she only had to give you 9, I believe, Chrissy. And now you're down to 31. You got 10 more to give, girl. Who else has 12? I think Jury does. Is that a 12 or a 16?
One or the other.
Well, let's say it's 16.
That's 16.
Mimi, go ahead and give 5 to her. You still got 5 to give. Why do I say she still has 5 to give?
Because that'd be on average.
Until she comes down, Ashley, to average. So when you add everything up and divide by how many you got, what is that 21 telling you again? Go ahead, Chrissy.
If everybody in the class could have something, it would be 21 ounces.
If we had 441 total ounces of beverage, split evenly amongst all 21 of you, you'd have 21 ounces each. That's what that's what an average does. It takes resources, throws them into a huge pile, and then doles them out equally to everybody that gets the resource. Is that fair? You see what's going on now? That's when you add up and divide by how many you've got, that's what it's doing. That's what it's doing. It's assuring that you have an equal number of whatever the resource is in each unit. So when there's 2.5 children per family in America in 1990, that means if every single family had kids, and they all had the same number of kids, they'd have to have 2.5 each. Even the ones that have none, and even the one that has 13, they'd each have 2.5 to have the same total number of kids. Can you see how this would be bad? You could misuse this. Can you see how you could misuse this? I'm not saying this is always a good thing or a telling thing. You guys have already picked on the fact of margin of error. It ignores the margin of error. It ignores the variability. Here's an extreme example. Here's an extreme example, okay? How many people we have in the room right now? We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 30. 30 people in the room right now. Brittany, if you don't mind, you're my computation master today. Let's divide 441 by 30.
14.71.
Thank you. I'm gonna call it 15 if that's okay with you. What would that average be right there? What would that average be right there? If I divide it by 30, which is the total number of people in the room, some of whom, as Christina pointed out about 15 minutes ago, don't have a beverage in front of them, yes? So what would that 15 ounces right there represent? Please, Sumi.
It would represent the equal amount of
You got it.
Of
Beverages.
ounces, right, of the beverages ounces to everybody that even people that don't have averages.
So thank you, perfectly said. Imagine this. Nobody actually has a 15-ounce cup. There was a 15.2. Where's my 15.2? Just, Ashley, if you don't mind holding on so I can get a visual. That's 15.2 ounces filled to the top. There's a second one. Oh crap, did I count that twice? I did.
You did.
Imagine an empty one of those in front of every single person in the room. Okay, with me so far? There's an empty 15.2 ounce bottle in front of every single student in the room. Then all of us that have beverages with us get in a line. And we start at the first person, and we fill that 15.2, and then we stop when it's full. And I go to the next, and I fill until either they're all full or I'm out. Once I'm out, the next person in line brings their beverage and keeps filling. It might taste kind of weird, but whatever. At the end of the day, when we get over to Mimi, who has a 15.2 ounce bottle empty, the last person's gonna go and fill it exactly perfectly, and then that big, or small, whatever it was, will be empty, and every single one of you in the room will have 15.2 ounces of some kind of beverage in front of you. Exactly the same amount. 441 total ounces is how much beverage is in the room, whatever it is, whether it's probiotic, whether it's coffee, whatever it is, whether it's just water, whatever it is, that's how much liquid is in the room. If you spread it out equally, that's what an average is. Is that fair? That's what an average does. I mean, when you guys add up and divide by how many you got, that's what you're doing. That's what you're doing. Does that make sense? Yeah. It's not always fair though, because if you think about that, 15 ounces per person, that means people that don't have liquid get some for free. Now you might have a problem with that. America generally has a problem with this. This is why things like socialism don't go over well in America. Why? Did you say what you were going to say? That's what you're going to say. I don't like socialism. That's okay.
No, I call it socialism, remember that.
You say I didn't catch that.
I call certain things weird things, I don't remember stuff, and that average I call socialism.
I call it the socialistic measure. That's exactly what it is. No, it is. It is the socialistic measure of center. I call it that in 243.
Yeah.
You have all these measures of center. You've got the mode, you got the median, you got the mid-range, you got the harmonic mean, the geometric mean. The arithmetic mean, we just calculated whether it's weighted or not. It's the socialistic center. If you took all the kids in America and chopped them up into little pieces and gave every family the same number, you'd have 2.5 kids per family. That's pure social. That's King Solomon type stuff, right? Split the baby. But that's what an average is. Have you guys ever kind of thought about that before? Just the computation we have, yes? The computation add up and divide by. But how many of you have thought about, like, that's why you do that? Right, nobody stops to, oh good, 2 of us, that's good. That's good. And the fact that you're calling it a socialistic measure means you understand exactly what's getting done there. But that's what an average is. It's an equal split of the resources. Assuming. Now, for the times up here, and we'll talk briefly and then kick you out of here for a break, and then come back and talk.